All right, let's do this. Take one. So Amrinder takes his boat. This is the one, right? That you had out for a spin, leading towards a cliff. He noticed that Dwayne the Rock Johnson is standing on top of the cliff. Amrinder stops and estimates that the angle of elevation, that's important, right? Angle of elevation to the top of the cliff is 50 degrees. Amrinder continues to travel another 200 yards towards the cliff to take a better look. Stops and estimates that the angle of elevation is now 60, which makes sense. The closer you get, the higher you're going to have to look, right? The bigger the angle of elevation. Sketch the diagram, label as much as possible. Here we go. It's good probably to have a ruler. It just makes it a bit cleaner, so we'll do that here. For A, the way I always come from left to right. So Amrinder's first position would be right there, and the rock is up here somewhere, looking up to the cliff, right? So the idea is that this is like it's a boat, right? So it's on the water. Obviously it would be wavy, but this is like my horizontal, so to speak. This is the cliff, right? So this is what, Dwayne? Rock, you can call it R, you can call it whatever you want. But we know that at first, okay, this angle of elevation here would be 50 degrees. So Amrinder moves closer to take a better look. So let's say over here somewhere, looks up again, and it's now 60. Okay, so this angle here is 60 degrees, angle of elevation. So that'd be Amrinder's second position. And we know that this is 200 yards at the bottom here. Like that. We have a 90 here. If we measured the top of the cliff, this would be representing the height of the cliff. Okay, so if you have that, you would get 2 marks for it. Label as much as show your work. So I mean label as much as possible. You could already fill in the angles that are missing. My diagram is rather small, right? But you could already say, well, there's a straight line here. So this is 120, okay? And then I know that 120 and 50 make up 170, which means that this is 10, right? So I would say if you have that filled in and the rest, you have 2 marks there already for the diagram. If you didn't label it in here, but you are somewhere else coming up with these numbers, I'm fine with that. That would still give you a 2 here. So I kind of look at the whole question and how you solved it. B, calculate the direct distance between Amrinder's second stop and the rock. So this is the second stop. And so we want the direct distance here, so that'd be x here for us, okay? And I'll be using this triangle here, the obtuse triangle, because I've got way more information in there. I've got actually a side length there. So let's start solving B. I will go sine of 10. This thing is across this side. So sine of 10 across 200 yards. So if I see the 10, I know you know this is 10. So if it's not labeled, it's not the biggest deal. And I'm going to use the 50 to figure out x, right? Because these are opposite each other. So sine of 50 degrees over x. So you cross multiply and divide. And that's divided by sine of 10. And that gives you 882.29. Yards, okay? Oops. All right. Yeah, now I'm remembering. You did this on the whiteboard, right? So this was just another go at it. I hope it helped you, because sometimes when you sit down and have to do this yourself, it's having 2 swings at it, right? Whiteboard, okay, we got it. Now I kind of know what to expect, and then you do another go at it. All right. So this is the answer. We already knew that. C, determine the height of the cliff. This is the height here. So I'm going to use this slant and that angle right there. So it'd be 882.29 times sine of 60. And that gives you 764.09. That's 1 mark there. Okay. So we've got 2 for the diagram. We've got 3 here. So sine law, I would say, the fact that you're using sine law, the fact that you're actually solving, and then the final answer. So 3 marks here, and 1 mark for the height. So this is a total of 6. So I don't know if you want to do this out of 6. And then we'll do question 2. I asked you to do the whole thing, right? Thank you. 2 ships leave the same port. So this is the port here. Boat A travels at a speed of 20 miles per hour. Boat B travels at 25 miles per hour. After 3 hours, they're 110 miles apart. So what we know, we don't really know which direction. Okay, so that's the frustrating part. So you just draw your triangle because it's not drawn to scale. Right? Just draw it like they're going in different directions. This is boat A for me, and this is boat B. Okay, so we know that after a certain amount of time, they're 110 miles apart. That we know for sure. We need to do something with the speed and the time. So you just go 20 miles per hour and multiply it by 3 hours. Okay, the hours cancel out, you end up with miles. So that's 60 miles here. And then boat B travels at 25, so 25 times 3, that's 75. Okay, so you've got your 60 and 75. So you get a mark for the diagram. And it's asking, calculate the angle formed between their paths. So this is one path, this is another path. So we need to figure this out. After you figure that out, technically you could now make a scale diagram, right? You could actually draw it to scale where it would be more realistic, but I'm not going to ask you to do that. So this is a side scenario. We have to use cosine law to figure that out. So cosine of P, right? I'm going to make sure the 110 is squared and subtracting at the back, and then the other ones are filling up the remaining spots. Okay, so 2 times 60 times 75, like that. So that would for sure get you a mark as well, the correct setup. Okay, cosine of P, if you do the top, you get negative 2875, and you get 9,000 for the denominator. Okay, that ends up being negative 0.319, and that keeps going. So angle P will be found. You have to use the inverse in order to find angles. And what does the negative tell us? This angle will be obtuse, guaranteed. So if you ever wanted to just investigate, is this an obtuse triangle? You could stop right. You could actually stop right there. It's like, ah, we're done. This is an obtuse triangle because it's going to be an obtuse angle. If that's all you were asked to do, but you actually want to find the measure. So if you go with that, that's 108.63 degrees. So 1 mark for setup, and then I'll just give you 1 mark for the work and correct final answer. If you missed the negative, which would have resulted in an acute angle, I would go -1, okay, on this one. So 6 and 3, that's 9 for this page. So 9 marks associated there. Next page. If you write the date of like today's date, or even, yeah, I would write today's date on top of this AC. If you want to look at the correction down the road, you know where to look which date to look up on the Google Classroom. All right, the U.S. military. I think you already know this one, but we have the height here of that air balloons. Has air balloons flying over international waters. Okay, this is how high above the water we are, and the balloon spots an unidentified object, an angle of depression, right? So U is at an angle of depression of 65 degrees, and a cruise ship at an angle of depression of 45. Assume that the balloon is in between. That's very important. okay? Because it would have been a completely different diagram had I not given you that piece of information. In fact, you wouldn't know exactly how to graph it. So they're in between the vessels being spotted. So for A, the balloon is up here somewhere, and let's just assume it's really up to you how you want to do it, but you could have the unidentified object here, right, and the 65 would go in there, so this is U, and then the 45 here somewhere, and that would be the cruise ship. So obviously they're on the same water, so it would be horizontal line down there, and we have a 45 there. We know that the height of this is 9,000, so you have no choice but to use right triangles when you're given the height. You have to resort to that. So this is my diagram. Is there anything that I'm missing? I think I'm good. You need at least one side length, or else you're dead in the water in this case. So you need one side length, or else you cannot solve any problem. Okay. Next, calculate the distance between the vessels spotted by the balloon. Okay, because of the height here, it's forcing me into two right triangles. So my options here are, this is the way I probably approach it. I will say, well, I'll figure out this stretch, and then I'll figure out this stretch and just add them up. That's one way of doing it. And we have a 90 formed here. So if this is 65, then this is 25. I should use a different color. If this is 45, then this is 45 as well. You could use sum of triangle to figure out this one, but you could also use alternate interior. So angles are just appearing everywhere. It's like the mystery angles all over again. Okay, so there we have it. This is 45, 45. So some of you didn't catch it, and that's okay, but this is an isosceles triangle, a right isosceles, by the way. So if this is 9,000, you could bet that this is 9,000 as well, because angles that are equal, they have the same sides across from them. So this is technically a done deal. You already know y is 9,000. If you didn't catch it, I know I saw you doing sine law, you're like, wait a minute, is this right? And I like how you questioned your answer, because you have to, you should, right? All right, so I'm going to focus on x here. So we've got 9,000 here. You've got 65 there. What else do I have? I want this one, and I know this is 25 up here. Perfect. We've got a pair, and that will get you that. So sorry that I'm going a little fast here, but I realized that you're already done. Right? So sine of 25 over x, cross multiply and divide, so that would be 9,000 times sine of 25 divided by sine of 65. X ends up being 4196.77. 4196 point. But I asked you to use 4 decimals, so I didn't do that. I'm going against what I told you to do. But I think it's still going to be the same final answer. So distance between would be 4196.77 plus 9,000. So that is 13,196.77 feet. Okay? So we get 4 marks. How are there 4 marks here? Well, I would give you just 1 for the 9,000. I would give you 2 to come up with the 4196. And then another mark to come up with the total, because you have to add. Okay? And 2, so 2 for the diagram, 4 for B. I should have specified that I'm solving for B here. And what's the distance kilometers? Hey, this is a blast from the past, right? I went with 1 mile, has 5,280 feet. That cancels out. And then I went 1 mile, has 1.6093 kilometers. Miles cancel out. So it's really this times that divided by that. And you get 4.02 kilometers. 1 mark for that. And it doesn't matter how you did it, to be honest. You should all get the same answer. It depends. It depends how much of a detour you took to get there. So sometimes because of the detour, your decimals may be off, but that's okay. We're gonna be okay today. All right. What's that last one? Oh yeah, Blast from the Past, Chapter 2, Polygons. I'm gonna do this one because if interior is 171, exterior is 9 degrees, right? Because we know that do you remember that? They add up to 180. And so I'm just going to say that 9 degrees is equal to 360 degrees over n. I put the 1 there, I cross multiply and divide. So it's 360 times 1 divided by 9. Okay? So that's 40 sides, which I did see a lot of you. And you can do it the other way, it doesn't matter to me. Whatever floats your boat. Okay? So we've got hold on, 6, 7, and 2. This is 9 here for this page, right? The total amounts to 9, and we've got 9 in the front. Okay, so that makes the total out of 18. You're the teacher. Come up with a number, and I will most likely accept